Hello, today we are going to see about the design procedures for flat belt drive. Basically, it is used when the distance between the two pulleys are about 10 meters and moderate power is required. And further, this flat belt is further classified into two types, that is open belt drive and cross belt drive. Open belt drive means the pulleys which rotate in the same direction. They are known as open belt drive. And cross belt drive are the pulleys which rotate in opposite directions. So let's go on to the design procedures. First one, unknown diameter or speed. The very first formula we use is N1 equal to N2 D2, where D1 is always the dia of smaller pulley. And N1 is speed of smaller pulley. Similarly, D2 is of dia of larger pulley. If the pulley size is small, then the RPM of the pulley will be more. So if diameter is small, N will be more. That is how we can find which pulley is smaller, which is D1, which is D2. So if they give, suppose, the diameter of first pulley be 250 mm and RPM be around like 650, and another dia of the pulley they give 350 and RPM be around 500, we get to know which is the diameter of smaller pulley and the RPM. Since like that we can correlate and get to know what is what. Speed of larger pulley, that is number of rotations pulley. If in case they give thickness in the question, then we use the formula N1 D1 plus T equal to N2 D2 plus T, where thickness will be given in the question. Second, we find the velocity. The formula V equal to pi D1 N1 divided by 1000 into 60 meter per second. Third, we find the capacity. To find capacity, the coefficient of friction will be given in the question. If they given coefficient of friction separately for smaller pulley and larger pulley, then we have to find the value of. Then we have to use the formula e power nu theta, where theta s and theta l will be given in data handbook by Lingaya, that is equation number 21.10a for theta s, 10b for theta s, that is pi minus 2 sine inverse of d minus d, which is this dia of larger pulley, the capital D, and D is smaller dia, by 2c. into pi by 180. Remember this pi by 180 is multiplied only within these brackets. To convert this into the radian form, you will get the answer in radian. C is the center distance between two pulleys. Two pulleys, or if they might give shaft length between two pulleys, we can use that as the C, and it should be in mm. Diameter also should be in mm. Now we see the theta L. Theta L is given by pi plus 2 sine inverse T by D to C into pi by 180. Nothing but only the plus sign changes, this sign changes, which is in equation number 21.10a. So we substitute the value of nu and theta, that is we find value of nu theta s and nu theta l if the coefficient of friction is given separately, and we take the smaller value, that is whichever is the smaller value. If nu theta s value is smaller, then we take that value. Whichever value is smaller, we take that. If only one coefficient of friction is given, that is only nu is given, then we directly substitute for nu e power nu theta s. Now let's go to next one, that is finding K constant. Fifth one, finding K constant. This is not the first and the second. This formula you have to keep it on your mind, and this, even the second one, as these two are not given. The rest are given in the data handbook, and the formula for constant also you have to keep it on mind, as it is not given in the data handbook. E power nu theta s minus 1 by e power nu theta, mean basically nu theta, whichever value you find here in the capacity, the nu theta value, that value you have to substitute here and find the value of constant, which has no SI units. Next, the sixth one, width of the belt or power transmitted. Width of belt or power transmitted. Per mm is equal to total given power is equal to sigma 1 minus sigma c of kV divided by 1000, where sigma c is the centrifugal stress given by W into V square by G into 10 power 6, where W is given by 10 into 10 power minus 6 Newton per mm. This is given in equation number 21.3b, where sigma 1 is the allowable safe stress. K value we will find from the previous, and velocity we get it from the second. Then after finding P, the power transmitted, we can find the cross sectional area of the belt, that is total power by P, power transmitted. Total power will be given in the question. If not, they might give the cross sectional area and tell you to find the total power. You have to find the power from here they might give the cross section area in the question. Also, cross sectional area is equal to B into T, where T is thickness, B is width of the belt. After, they might tell you to find the width of the belt in the question. After finding the width of the belt, we have to select the value from the standard table of standard width of the belt dimensions, that is given in the page number table number 21-8, standard width, table 21-8. After finding the width of the belt, we have to find the length of the belt. Length of the belt. It is given in the equation 21.7. L equal to, for open belt, L equal to root of 4 C square minus diameter of bigger dia minus smaller dia plus 1/2 d theta L plus small d theta S. This is for open belt. Now for cross belt, it is given in equation 21.8. L equal to, sorry, this is 4C square. L equal to root of 4C square minus D plus D plus theta by 2 of D plus D. Now further, next they might ask you to find the initial tensions or tensions in the pulley. Initial tension is T0. Tension in the belt are T1 and T2. From equation number 21.12, we get the formula 2 root T0 equal to root T1 plus root T2, where T1 equal to sigma 1 into area of cross section and T2 equal to sigma 2 into area of cross section. To obtain sigma 2 value, it is given in equation number 21.3a. 21.3a, that is sigma 1 minus sigma c divided by sigma 2 minus sigma c equal to e power nu theta. From here we get the value of sigma 2. From here we get the value of sigma 2. After finding the value of sigma 2, we substitute here, and then after finding T1 value and T2 value, put it here and find the value of initial tension. That's it. Thank you. If you have any further doubts, you can comment below.